Welcome to lecture 42 of the course Modeling and Ticket Simulation of Solar Photovoltaic Cell. In this lecture, basically we will continue the solution whatever we were discussing in last class. So in last lecture, we stopped after formation of node equations of the semiconductor device portion, that is depletion layer of a PN junction within P region. So up to formation of node equations we covered in last lecture, and in this lecture we will show you how to solve these node equations through iterative method. We will cover both the methods. First we will discuss Jacobi method for updation of nodes, and then Gauss-Seidel method. So this was the last set of equations we have obtained after using the 5-point formula and after using the boundary conditions. Now here you have to remember one thing. Always you have to update the values which are associated with the 4 term. That means for equation n5, here you have to find out the phi 1 1, and for equation n6, so phi 2 1. So that means the point where you like to calculate the potential, and you remember that this equation n5, that is actually originated from the node 1 1, for node 1 1, this equation. So starting from the differentiation for node 1 1, we got this equation. This is for node 1 1. Node 1 1. This was for node 2 1. I can recognize by looking the 4 multiplication term. This is for node 1 2. And this equation for node 2 2. If you remember, this equation n5 is formed from the 5-point formula for node 1 1. So this equation basically for node 1 1. This is for node 2 1. I can recognize by looking this 4 multiplication term here, and this is for node 1 2. This is for node 2 2. These set of equations will start the iteration method. Say for the first equation, that is we obtained from the n5, equation number n5. Let us try to find out the phi 1 1 value, because this equation was for phi 1 1 as I mentioned. So from the last page, that is this equation, so if you calculate the phi 1 1, so this phi 1 1 will be phi 1 2 plus phi 2 1 minus 100 whole divided by 4. So here phi 1 1 you try to find out in terms of other node values, because this equation was started from the node 1 1. So phi 1 1 is nothing but this. Actually phi 1 1 this is phi 1 2 plus phi 2 1 minus 100 whole divided by 4. So that's why it is 1 by 4 phi 1 2 plus 1 by 4 phi 2 1 minus 100 by 4. And phi 1 1, so this 0.25 phi 1 2 plus 0.25 phi 2 1 plus minus 25. Again, for the next node, that is from the N6 equation, if we write, this is for, it was basically for node 2 1. So phi 2 1 we represent in terms of other node values. So 0.25 again the same way, in the same way is 0.25 phi 1 1 plus 0.25 phi 2 2 minus 90 by 4, that will be nothing but 22.5. So this is say equation number N10. Similarly, for other equation, next equation, that is for phi 1 2, this phi 1 2 value 0.25 phi 1 plus 0.25 phi 2 2 minus 25, and for 2 2 phi 2 2 is 0.25 phi 1 2 plus 0.25 phi 2 1 minus 22.5. And you should remember that in all the equation, the node value, except the desired node value, interior node, other node values are present. So for the Jacobi method, we have to update iteration wise. So first these 4 values we have obtained for nodes phi 1 1, phi 2 1, phi 1 2 and phi 2 2. What is the next step? Next step is we have to again compute the value of phi 1 1 using this equation, but putting the values of phi 1 2 and phi 2 1 in the latest value. So how can we update this? Suppose we take an initial guess. Initial guess of these interior values, because boundary values are not required, boundary conditions are given. We have already put the boundary condition. So initial guess for these 4 nodes, let us take 0. Maybe a wrong guess, but you can start with the 0. You may start with 5, you may start with 10, it doesn't matter. But let us take 0. 0 is very conventional. If people take the initial guess is 0. If it is 0, all these interior node values, initial value, what will be the phi 1 1? If phi 1 1 will be 0.25 phi 1 2, that is 0 into 0.25 plus 0.25 into phi 2 1, that is also 0 into 0.25 minus 25. So ultimately phi 1 1 becomes minus 25. If we put this equation, the value in the equation, this is also 0.25 phi 1 1, that is also initial guess is 0. But already phi 1 1, whatever is obtained here, minus 25, that is not used in this case. That will be used in case of Gauss-Seidel method. That is, in the Gauss-Seidel method we mentioned in last class that the in place and immediate value of the node is updated. That is, whenever you are computing phi 2 1 and where phi 1 1 comes, you have to put this phi 1 1 as a latest updated, that is last value, that is minus 25. But in Jacobi method we will not do that. We will do the total set of iteration will remain same, and next iteration it will change. So the phi 1 1 is minus 25 obtained by putting this guess value, but we will not use that value in this equation for Jacobi method. Be careful. So phi 2 1 will be 0.25 phi 1 1. So this is also 0 plus 0 minus 22.5. So phi 2 1 will be minus 22.5. And phi 1 2 will be 0 0 minus 25, and phi 2 2 will be 0 0 minus 22.5. So we can summarize in this way. Say phi 1 1 in the first, or it is called a 0th iteration. You can say this is a 0th iteration, or this phi 1 1 0. This is coming minus 25. Phi 1 phi 2 1 2 or 2 1, whatever you write 2 1 first. 2 1 0. That is coming minus 22.5. phi 1 2 for 0th iteration you are getting minus 25, and phi 2 2 iteration you are getting again minus 22.5. These four values for iteration 0 you are obtained. Now again, if you put the, it is written here, it is shown actually, whatever the calculation, yes, it is shown here in the same way. Already I have discussed this one. Again, if you put this value, so before that, you just again summarize. Again, I am writing these values. Here actually, we have written it is a 1th iteration. So initial guess as a 0. So let us write it is a iteration 1. So let us write these are iteration 1. Because initial guess are iteration 0. We should write here 1, first iteration, because these are put these are initial values. So we can summarize here phi 1 1 1 is equal to minus 25, phi 2 1 1 that will be minus 22.5, phi 1 2 1 this is coming minus 25, phi 2 2 1 that will be coming minus 22.5. These values will be used again to compute the values of phi 1 1 using that equation, that is basic equation that we have formed, that is N9, N10, N11 and N12. We will be putting these, we will be using these values again, these equations again to compute the second iteration value of the phi values. So this again if we put, so this now let us put this phi 1 1 as a 2. So this is 0.25 into phi 1 2 1. This is from N9 equation, you know, basically using equation N9. 0.25 into phi 1 2. Now this phi 1 2 value will be the first iteration value, that is minus 25, and 0.25 into phi 2 1 1. So this phi 2 1 1 is minus 22.5 minus 25. So these values will be used. So the what will the values? Phi 1 1 2 will be coming 0.25 into minus 25 plus 0.25 into minus 22.5 minus 25. It will be coming at minus 36.875. We have calculated. So this value is second iteration value of phi 1 1. Earlier value of phi 1 1 was minus 25. Now it is increased to minus 36.875. Be careful, and one thing you observe, initial guess was 0. So 0 to minus 25, what is the change? Change is minus 25. And now minus 25 to minus 36.875. What is the change? Change becomes less in mod value of the change, coming low. So gradually lowering this difference from the successive two iteration values, between two successive iteration values will become low, and when it converges it will be very close, then we will stop. So let us calculate for other values. So phi 2 1 2, so using equation N10, yes is N10, let me confirm, yes N10. And this is coming at minus 34.75, 375. In this way if you proceed, so it will phi 1 2 will be coming minus 36.875, that is also using N11, and 2 2 phi 2 2 is minus 34.375. If you repeat the expression, now in the third iteration you have to put these values of the updated values of the nodes again into the equation number in 9 to 12. So what will be the values? If we do this third iteration, phi 1 1 will be coming minus 42.125. Phi 2 1 third iteration will be coming minus 40.3125, and this way we are getting these values. So if you compute in the tabular format these values for iteration to iteration, you can observe the change in the values becoming low and low. So let us summarize the values first from the earlier slides. So let us say initial guess was 0 and minus 25 minus 20, this is the first iteration, 25 25 minus 22.5, 22 and 21, 22 and 21. So let us summarize here in this way. Here suppose phi 1 1, phi 1 2, phi 2 1 and phi 2 2. And you see this is the iteration value, iteration number. So 0, initial guess was 0 0 0 0. First iteration minus 25, two 1 and 2 2, $22.5. Iteration number 2, one 36.875, 34.375, 1 1 then 2 1, 36.875 minus 36.875 minus 34.375. 34.375 and other values 1 2 2 2, 36.875, same value repeating. Then the third value minus 42.8125, minus 42.8125, 42.8125, 42.8125 and 40.3125, 40.3125, 40.3125 minus sign. So you observe the change in the values. Still there is a change, huge change, minus 36, minus 42, minus 36, 42. So you have to continue until you get the value almost same for two successive iterations. In this way, but it is difficult to calculate now, that's why I am not showing, but you remember this is the value we have to compute in a computer programming. you have to continue in this way until phi 1 1 value at k plus 1 iteration almost equal to phi 1 1 k iteration, or you can set some error value, say error E. Error is, suppose this epsilon is permittivity, so let us E. E suppose error. You can define as the modulus of phi 1 1 k plus 1 minus phi 1 1 k value. So stop if E say less than equal to 0.001. In this way you can set to get the converged values. Now let us consider the process Gauss-Seidel method, and there also you observe how these are iteration is going on. Let us see Gauss-Seidel method. So again we start from the equation with initial guess and the values, equation number n9, n10, n11 and n12. We have to update. But one different thing observing here, say from n9 equation, the value of phi 1 1, that is 0.250 plus 0.250 minus 25, that is minus 25, as the same like a Jacobi method. Similarly phi other values are there, so phi 2 1, one iteration we can calculate now. So the equation was for phi 2 1, in right side there is a content of phi 1 1, 0.25 into phi 1 1. In the equation number n10 you can see n10 there is a, so 0.25 into phi 1 1 1 in the expression, because it's previous. But how this one will be used? In Jacobi method we have shown you that phi 1 1 is used for the initial guess value phi 1 1 0. But here in 1 itself iteration you can use phi 1 1 1 itself. That is the thing, that is the difference, that is the in place update. So in Jacobi it was phi 1 1 0 in case of Jacobi method of updation. But here itself already phi 1 1 you obtained minus 25, this value you can put here, this minus 25. Plus the formula is 0.25 into phi 2 2. Phi 2 2 is not already calculated. Phi 2 2 is earlier to this node is not calculated. So remain phi 2 2 is 0 value. 0 minus 22.5. So after putting this value you see difference. Phi 2 1 will be minus 28.75. So in Jacobi method phi 2 1 was some 34 point something. I don't exactly the values. Anyway, so this is coming. And same way for the next, say phi 1 2, how can you calculate the phi 1 2? Phi 1 2, that will be 0.25 into minus 25. This value already of the phi 1 1 plus 0.25 into 0. 0 means this value was all not updated. Phi 2 2 value was there, so that's why this is 31.25. And the phi 2 2, that will be 0.25 minus 31.25, because this phi 2 2 contains this updated value, this phi 1 2. So phi 1 2 updated value is used here. So this is the updated value. This is actually, this value is phi 1 to 1 value. So in the same iteration, first iteration, we are using the latest updated value of phi 1 2. This is the difference in the Gauss-Seidel method. Plus 0.25 into minus 28.75. Again, this value is minus 28.75. This is a phi 2 1 value. So this is a phi 2 1 value. Phi 2 1 is the first iteration. Minus 22.5. This is minus 37.5. In this way, if you continue, you will get the more faster conversion in this case. We will show the tabular form, how these values are changing, and we can compare with this value with the earlier table. So this is Jacobi, no, this is should be Gauss. So let us tabulate again. 511, 512, 521, 522, and say number of iterations you write. Iteration number 0, 0, there is initial guess 1. For 1 it was, what is the value? Minus 25. I exactly minus 25, minus 28.75, minus 25, minus 28.75, minus 25, minus 28.75, minus 28.75, 1 to minus 31.25, minus 31.25. Minus 37.5. And if you compare, so you have to do the second iteration. Say 511 second iteration. You have to write the formulas of these equations. So let us summarize equation here. So 511 is equal to 0.25, 511 is equal to 0.25, 512 plus 0.25, 521 minus 25, this is equation N9. 521 is equal to 0.25, 511 plus 0.25, 522 minus 22.5, that is equal to N10. 512 is equal to 0.25, 511 plus 0.25, 522 minus 25 equal to N11, and 522 is equal to 0.25, 512 plus 0.25, 521 minus 22.5 is equal to N12. So using in place update values of the nodes. So in the second iteration, it can be shown that using this N9 to N12, so the values of these 511, that will be coming, this is minus 40, 521 will be minus 41.875, and 512 will be minus 44.375, and in this case this is minus 44.0625. So in the third iteration, fourth iteration, you have to continue and to observe the difference between these two values. So here also you observe that 0 to 25, the difference values is reduces from 25 to 40 here. Here also the big difference from the initial step, it is coming low. For all values it is coming low. And if you compare with this value with the Jacobi method, in some particular sometimes of some problems, you can see that in most of the cases, generally, Gauss-Seidel gives you the faster convergence than the Jacobi method. So after formation of the node equations, that is linear algebraic equation, you can proceed for the two types of iteration to get the final converged solution of interior node values. So in this lecture we have shown the 2D Poisson equation solution by iterative method. Two types of iterative methods, that is process of updates of the node values, that is Jacobi and Gauss-Seidel, is shown with an example. And it is observed that convergence in Gauss-Seidel method is reached very quickly. This is the advantage, because you are updating the values always. Even in a particular iteration, the value of a particular nodes in the same iteration may be used to calculate the node value at other points. So this is the main characteristics of the Gauss-Seidel method. So the reference, these books, and along with that some numerical techniques, mathematical books you can find for solution. Thank you.